We've learned how to determine charges for main group ions. We've learned how to write the name for main group ions, both cations and anions. We've also learned how to write the name when given the chemical formula. Now we need to turn that around. How do you write the chemical formula for an ionic compound when you're given the name? We have to find the smallest repeating unit of that compound. Previously, when we were looking at molecules, we talked about carbon dioxide. And carbon dioxide really is one carbon and two oxygens. You've got covalent bonds between the carbon and the oxygens, sharing of electrons. And the smallest repeating unit really is CO2. And because of the use of prefixes, if you're given the name, the chemical formula follows: carbon dioxide. And when you're given the formula and you write the name, you use prefixes: CO2, carbon dioxide. That really is the smallest repeating unit. Ionic compounds are different. There's no sharing of electrons between the ions. You end up with a transfer of electrons, which gets you cations and anions, and then they attract each other because of opposite charges. An ionic bond is an electrostatic attraction. Sodium chloride. This is a magnified grain of sodium chloride, just like something that would come out of your salt shaker. We need to find the smallest repeating unit. Well, in that little teeny grain of sodium chloride, there are approximately 10 to the 18th units of sodium chloride. All right, that doesn't help. That's overwhelming. If you study crystal structures, you'll learn that sodium chloride forms what's called a cubic closest packing crystal structure. The green ones are chlorides, and the purple ones are sodiums. And that's the smallest repeating unit out of that crystal structure. Both the sodium and the chloride ions form what's called face-centered cubic lattices. And when you put those lattices, that's not helping, is it? Now, I can't look at that and go, oh, sodium chloride's NaCl. There has to be another way to figure out the smallest repeating unit. And that other way is charge balance. The smallest repeating unit of an ionic compound will be neutral. In other words, you'll have just as much positive charge as you have negative charge. So sodium chloride, you have to recognize that's an ionic compound immediately. Remember the generalization. Metal bonded to nonmetal. The metals first, the nonmetals second for binary ionic compounds. Sodium's a metal. You expect metals to form cations. Chloride comes from chlorine. It's a nonmetal. You expect nonmetals to form anions. Then you look at your periodic table, and you need to have your periodic table out for this part. Remember, sodium has a positive charge on it because it's in 1A, whereas chloride has a minus charge on it because it's in 7A. So you have to put in a certain amount of sodium ions and chloride ions such that when you're done, it's neutral. All the positive and all the negative charge balances out. And since they're both 1, it's just one's a positive, one's a negative, you just need one of each. There's the chemical formula, NaCl. And notice in that chemical formula there are no charges. Do not put charges in the chemical formula for an ionic compound. You put it on the individual ions, but not when you write the compound. It's wrong. Let's do some examples. Potassium chloride. I'll just say this part for this one, and then you have to assume that all the way throughout. We're talking about binary compounds, and we're talking about ionic compounds. So you always have to be aware of metals and nonmetals. You do not use prefixes on the ionic names. So you can't look at potassium chloride and go, oh, automatically there's one of each because there are no prefixes. That's not the way it works. Charge balancing. Potassium ion, group 1A, positive charge. Chloride ion, 7A, minus charge. Positive, negative, they balance themselves out. And there's the chemical formula, KCl. Calcium fluoride. Calcium, group 2A, 2 plus. Fluoride, 7A, 1 minus. Now the charges have to be equal, but they're not. So that means we have to take a multiple of them such that when we're done, you have the same amount of positive as negative charge. So the least common multiple of 2 and 1 is 2. So you take 1 calcium ion, and how many fluorides? 2 fluorides. So now you have a plus 2 and a minus 2. Aluminum ion, 3A, so it's 3 plus. Sulfide ion, 6A, so it's 2 minus. The least common multiple of 3 and 2 is what? It's 6. So you need a total of plus 6 and minus 6 to balance themselves out. Take 2 aluminum ions, there's your plus 6. Take 3 sulfide ions, there's the minus 6. Group 1A, so positive for potassium. Group 6A, 2 negative for sulfide. The least common multiple of 1 and 2 is 2. That gets you 2 positives and 2 negatives. Aluminum ion, 3 plus because it's in 3A. Fluoride, minus because it's in 7A. So the least common multiple of 3 and 1 is 3. So how many aluminums do you need? And how many fluorides do you need? 1 aluminum gets you a 3 plus, and 3 fluorides gets you a 3 minus. Magnesium ion, 2 plus because it's in 2A. Nitride, 3 minus because it's in 5A. The least common multiple of 2 and 3 is 6. So 3 magnesium ions gets you a plus 6, and 2 nitrides gives you a minus 6. So remember, cations before anions. When you write the name of the compound, do not include prefixes. No monos, dis, and tris for what we're doing. When you write the chemical formula, like KCl or AlF3, don't put the charge in the formula for the ionic compound. You only put charges when it's the ions all by their lonesome.